Hello, this is Dr. Oz. In this video, I would like to talk about time series analysis and forecasting. So forecasting methods could be either qualitative and quantitative. Qualitative methods are in general for complex situations where it's so hard to come up with a predictive analytics using data. Either data is not reliable or not available, or the environment is so complex and constantly changing. And in this case, on those cases, we use expert judgments to develop our forecast. In this video, I would like to talk about quantitative forecasting, and we use it when we have past information available for us, and also that past information can be quantified. And also another condition for this is that past is prologue the future forecast. All right. So in this video, I would like to talk about horizontal pattern, trend pattern, seasonal pattern, trend and seasonal pattern together, cyclical pattern, and identifying time series patterns. So the horizontal pattern occurs when the data fluctuates randomly around a constant mean. What do I mean by that? So let's say this is your data. On your y-axis, you have sales in dollars. On your x-axis, let's say you have time, let's say months. So the data fluctuates something like this, which as you see here, the mean for this data is constant over time, and as you see, the variation really doesn't change so much. So that's why we call this a stationary time series, where the mean is constant, it doesn't go up or down, and the variation around mean for data is constant as well. So let's take a look at an example here. So you can see that gasoline sales, and in this case, I have 12 weeks, 3 months of data, and the sales for gasoline is given thousands of gallons, and this is the data. It's hard to see data like this, so if you create a chart using that data, you can see that the mean is somewhere around, I would say, 20, and the variation, when you look at it, you don't see so much variation. So what do I mean by that again is that variation is nothing like small and a huge, or it's not like huge and small, huge, and so on. So this wouldn't be an example of stationary time series. But as you see this data set right here, I don't see the variation change a lot over time. Okay, so now I would like to introduce a little bit more complexity to this data set by, let's say, we have still 12 weeks of sales for this gasoline. However, now after week 12, we have a contract with Vermont State Police Department. And if I draw the graph, as you see here, our first time series data is around 20, but then the second one is around 30, because again there is a big jump here from here to here because of the police department contract. But this doesn't mean that we can assume that there is a trend over time, because this is one-time activity that there's a jump. That means that if I lose this contract, probably it will go back down. So if I'm trying to make a forecast, excuse me, I would either assume that this demand will stay constant over time in the future. If I think that I can keep the contract with the Vermont State Police Department. However, if I think that I can't, probably I should assume that this forecast will be around here. All right. So now we talked about the horizontal pattern, and horizontal pattern with the trend, the contract which will increase the step function. But what if I have data that has trend pattern in it, which means over time the values either go down or up? Trend can result in many different factors. For example, change in population could cause trend, because if I have more and more population, it will cause trend to be upward, more and more sales. If I have decrease in population, I may have less and less sales. Or change in competition in the market. If I have more and more competition in market, it may go down, or it may go up if I have less and less competition. Or change in technology. Again, if I invent new products and it exceeds beyond the expectations of my customers, I may sell more and more. However, if I cannot satisfy the expectations of my customers, may go down and down. So there are different factors can cause trends. So let's take a look at the bicycle sales time series data here. These are all thousands of dollars or units. So as you see this data, when you plot it, you can see the trend here going upwards. Sales is going higher and higher. So that's why it's better to use a trend line here. Let's take a look at another example, which is for drug revenue problem. And if you draw a pattern here, so using a linear line probably wouldn't be the best in this problem, because if I use a linear line, probably it would look something like this. However, if I use a nonlinear, maybe exponential line, it may look more like this. So I would say this exponential line is better than uh, this linear line, because the data is going higher and higher with the change, with let's say percent change of, I don't know exactly here, but let's say 5%. So that constant percent growth will create exponential growth, because let's say if I have 100 sales or revenue, next year I will have 105. But if I have 105 next year, the year after will be even more than 5 units, because 5% of 105 is greater than 5% of 100. So it will accumulate more and more. Okay, so that's trend line that we talked about for linear and non-linear. So far we talked about horizontal line with step function, second step. Then I introduced linear function, trend line, and then I introduce exponential trend line. All right, so what if I have seasonal patterns? So my data may have seasonal patterns because of different factors, such as restaurants sell more and more food on Fridays and Saturdays because people go outside on Friday and Saturdays more than Mondays and Tuesdays, let's say. And for example, ice cream sales and water sales are higher in summer because of the weather pattern. Or I may sell more and more sport gear throughout the sport seasons, a basketball season or baseball season. So there are different factors that could cause to have um, seasonal patterns. Let's take a look at this umbrella sales time series data. I have here 5 years of data. Each year has 4 quarters. And if I plot this data, you can see something like this. So what do I see here? So this is my quarter 1, this is my quarter 2, quarter 3, and this is my quarter 4. 1, quarter 2, 3, quarter 4, 1, quarter 2, 3, quarter 4, 1, quarter 2, 3, quarter 4, 1, quarter 2, 3, quarter 4. As you see here, I see seasonal pattern, because quarter 2 sales are greater than quarter 4 sales constantly. So that means that there's something going on in quarter 2s. Maybe I'm giving special discounts on quarter 2s, or maybe quarter 2 for this company is the Christmas time or holiday season. So in this kind of data set, you cannot just use a trend line or horizontal line to explain data, because you need to consider the seasonal patterns to adjust your forecast. So let's take a look at here another example that has seasonal pattern as well as trend together for smartphone sales. In this case, I have 4 years of data quarterly. If we create a chart here, you can see that this quarter one, and this is your quarter two. So quarter three, quarter four. So it looks like quarter four is right here, quarter two is right here. Quarter one, quarter two, and then quarter three, quarter four, quarter one, quarter two, quarter three, quarter four, quarter one, quarter two, quarter three, quarter four. As you see here, again, you see a seasonal pattern. Quarter four sales are greater and quarter two sales are the lowest. However, this time we observe that there is an upward trend. So my sales is going higher and higher on average. Another pattern that I would like to talk about is a cyclical pattern. So especially I see in stock market and economy that we have cycles, but the cyclical pattern differentiates from seasonal because seasonal patterns are within a year. So it could be quarterly, it could be monthly, it could be daily, and so on. However, cyclical patterns are throughout the years. For example, if you look at S&P 500 index or economy, you see this kind of cycles. Right? So basically, every um, 6 to 10 years, we have upward stock market movement, which is we call bull market, and then a year or two, we have bear markets, downwards, bull markets, bear markets, bull markets, bear markets. But overall, you see U.S. economy, it's going up and up and up. So that's why we call this was a cyclical pattern, because it repeats itself every 6 to 10 years, which is more than a year time frame. Okay, so that's it for this video. Next video, I would like to show you how to create charts for these data sets using Excel. Until next video, enjoy business analytics.